Hey everyone, I wanted to do a few examples to show you how the use of your calculator can make what looks like rather intimidating material to start off chapter 2, the systems of linear equation stuff. Your calculator can really make short work of a lot of this stuff. So as I mentioned, the homework help and the textbook kind of are expecting you to do this by hand. I am not, and for that you are very welcome, because this stuff is very tedious. So I want to do a quick example of kind of one of the three types of problems that can show up. So if you've been watching those videos and doing your reading, you might remember that every system of linear equations falls into one of three categories. It has exactly one solution, it has no solutions, or it has an infinite number of solutions. The first couple are really easy. The third one takes a little bit of work. But a vast majority of what you see here in chapter 2, including the word problems, is going to be easy. It's going to be kind of the sweet spot where you have exactly one solution. And so I want to take you through an example of one of each of these. Okay. So on the top left, I have a system of three equations and three unknowns. I'm calling them X, Y, and Z. It doesn't matter what you call them. Okay. So what I'm going to do is I'm going to enter that system of equations into my calculator, but I don't actually do it as is. I use what's called a matrix to represent my system. So for a matrix, which right here I'm calling A, you can call it just about whatever you want. Your calculator has some names built in. What I'm doing is I'm first kind of lining up my unknowns all in the same order. So in each equation, I have X first, Y second, Z's third. Okay, if I had more unknowns, I would put them next. And on the right-hand side of the equal sign, I have the constant terms, and that are basically they're the numbers that aren't attached to unknowns. Okay. So I represent each equation by a row in a matrix. And all I do is I write down the coefficient or the number sitting on that unknown. So for the first equation, I have 2x's minus y. So 2x minus 1y plus z. So that's just plus 1z. We don't bother writing the 1 usually in multiplication, but I have to in the matrix world, equals 6. Second equation is 1x, 2y, minus z, minus 1, equals minus 5. Third equation is x plus y, so I have 1x and 1y. In the equation world, when an unknown doesn't show up in an equation, you typically just leave it empty. But in the matrix world, you have to write that as a 0. You have to put something in there, your calculator will complain, it'll be right to do so. Okay, so a little notation that goes with this is this matrix is said to be a 3x4 matrix. It's got 3 rows and 4 columns, so it's a 3x4 matrix. Okay, and it includes the right-hand side pieces, the things that aren't attached to unknowns. 6 minus 5 minus 1, they're like the constants on the right-hand side of the equal sign. So this is called an augmented matrix. Not a huge deal for us, but you might see the word. Okay. So the hard part is simply putting that matrix into my calculator. So I want to show you how this works. And I think, oh, there it is. Okay. All right. So what I'm going to do, oh, by the way, all these TI 83s and 84s have this matrix capability. If you have a different brand or a different model or something, you may or may not have it. If you don't have one, go out and borrow one for the next few weeks, because it's going to make life a lot easier if it does this RREF stuff. Okay. Nowadays, they actually sell some of these. They advertise, hey, it has the RREF command for doing this. By the way, RREF stands for Row Reduced Echelon Form, which is a mouthful. Basically what it means is your calculator is going to take a system of equations and it's going to use these fancy row operations by adding equations and multiplying equations and subtracting things, and it's basically going to spit out a system of equations or a matrix corresponding to a system of equations that has the same solutions as the system that we started with, but it's much easier to deal with. Okay. All right, so back to the calculator. So the first thing I want to do is I want to create a matrix. So I do that by doing second, and you'll see down here I have a blue matrix above my x to the minus 1 button. So I hit that. First thing I want to do is I want to cursor over because I want to edit a matrix. I'm setting one up. So I have lots of slots I could put this one in. I always take A if it's available. It makes my cursoring minimal. Okay, so I'm going to edit A, and it's asking me for the size. So I need a 3x4 matrix. So click 3, enter 4, and you'll see that now I have something of the right size. Now I just put in the numbers, same order. So I have 2 minus 1, 1, 6. 2, enter, minus 1, enter, 1, enter, 6. That's my first row. I hit enter, it brings me down to the second row, just as I would expect. So 1, enter, 2, enter, minus 1, enter, minus 5, enter. And lastly, 1, 1, 0, minus 1. Okay. And I'm telling you right now to always double check whatever you put in your calculator, because your calculator will be happy to work on whatever garbage you put in there. So double, triple check. So I have 2 minus 1, 1, 6, 1, 2 minus 1, minus 5, 1, 1, 0, minus 1. Looks good. Next thing I want to do is I want to get out of this little editor. So I hit the second button, and the one next to it will now, that has quit above there. So it's going to quit that editor and bring me back to my home screen. Now I want to tell my calculator to do those fancy RREF operations. Okay, so that's also in the matrix menu. So second matrix, missed it, there we go. Cursor over to the math and go way down until you find RREF. It's just past the bottom here, I think. There we go. Okay, it's not the one with 1 R. We don't do anything with that in this class. It's always the one with 2 R's. 2 R's is better than 1. Select enter. Your calculator now says, okay, I'm going to do RREF. Now I have to tell it what matrix I want it to do it to, because I could have several different matrices in my calculator at the same time. So second matrix, one last time. The very first menu is where I tell it what matrix I want it to work on. So 1's the default. I can just hit enter, or I can type 1. Okay. And it says, okay, I'm going to do RREF to this matrix A. Hit enter. Okay. And what comes out is another matrix. Now, what equations correspond to the rows of that matrix? Well, the first one is just 1x, no y, no z, equals 1. Let's see if I can move this. There we go. X equals 1. My second equation is just 0x plus 1y plus 0z. In other words, y by itself equals minus 2. And the last one is 0x plus 0y plus 1z equals 2. So in this form, you can kind of just read off, x must equal 1, y must equal minus 2, and z must equal 2. There are my solutions. Okay. In the homework, they usually want you to write this in what's called point format. So point format is just those 3 numbers as the coordinate of some point. We're not going to do much with or anything with drawing these things. So you're welcome, but that's kind of where this notation comes from. So in the point format, we just kind of write them in alphabetical order or whatever order we've been using. Your homework will kind of tell you what order to do things in. So x is 1, y is minus 2, z is 2. Okay. That is going to be, like I said, 95% of your homework problems will come down to, hey, set up the equations, put in a matrix, have your calculator do RREF to that matrix, and read off the solutions. Okay. The other 10% is a little bit where the headaches come from. Actually, one of them is no headaches whatsoever, so let me do this briefly. Okay. Let me see here. So my second one was here. Okay, so a similar system, I just changed a couple of numbers. Okay, so I'm not going to bore you with how I did that RREF or set that matrix up, but that's what I did again. So I did an A equals, and you'll notice it's basically just the matrix representation of that system of equations. Okay, I did RREF to it on my calculator, and I got out this matrix. Okay. I can tell right now that this system has no solutions. And the way I can tell is that bottom row right here represents what equation? So it's 0x plus 0y, I have it written over here, plus 0z equals 1. There's no way that you can solve that. You can't make 0 times something plus 0 times something plus 0 times something equal to anything but 0. So if I have an equation like that at the bottom, and they're all going to look like that when I have no solutions. At the bottom, I'm going to have a 0, 0, 0, as many unknowns as I have, and then 1 at the end. Okay. When you see that, you can stop. You have no solutions. Okay. The fancy word for that is inconsistent. By the way, when I did my RREF, this thing spat out a matrix with decimals in it, which are okay, but your homework might want stuff in fraction form. So when you do this, after you get this answer on your calculator, just hit the math, hit enter, and hit enter. Okay. Basically what that does is the first math menu option is to take your answer and to convert it into fractions. So math enter enter will do the entire matrix at a time. So it will take this, what comes out of your RREF, you hit math enter enter, and it spits out these things in fraction form. Okay. I wouldn't have bothered in this case because I would look at that bottom equation and say, hey, that's my tip off that I have no solutions whatsoever. Okay, so the third case, 5% of your problems, 25% of your, 50% of your headaches. I believe that is going to be this one. Okay. So again, looks very similar. I just changed some numbers to make what I want to happen in this example happen. Okay. So again, I started with this example, this system of equations, going to put it into my calculator in matrix form. I do RREF. Okay. You will notice here that I don't have a 0, 0, 0, 1. I have 0, 0, 0, 0. That's a little different. That equation is basically telling me that 0x plus 0y plus 0z equals 0. In other words, 0 equals 0. Okay. That's not terribly surprising. So what's going to solve that last equation? Anything solves that last equation. So it's the opposite of the last one where we had 0, 0, 0, 1 where nothing solved it. Okay. So in this case, what is going on is that I end up with a complete row of zeros in every slot in that row. Basically, that is telling me that the two equations above it kind of combine in such a way to give me that third equation. In other words, I don't really have three different relationships in this system of equations between my three unknowns. I really only have two of them. Okay. One of them kind of is a combination of the other two already. Okay. So when I did my RREF, I got out decimal stuff. I hit math, enter, enter. Okay. And I got out a fraction, or I got out fractions. So what I did here is I just wrote down the equations that correspond to this RREF matrix. So I have 1x, no y's. I have 1/5 z, which often is written as just z over 5, equals 7/5. So that's my first equation. My second equation is 0 x's, so I didn't bother writing the x's. No x's there. 1y minus 3/5 z, or 3z over 5, because it's the same thing, equals minus 16/5, and 0 equals 0. Okay, so that 0 equals 0, again, that's called a redundant equation. That's telling me that I didn't really have three real relationships between these three variables. I really only have the two. Okay, so the way this works is you'll notice that my first equation, x, is kind of the first variable that shows up. I'm reading left to right. So x is called a leading variable. Y gets to lead off the second equation, so y is a leading variable, but z never gets to lead off an equation. Okay. So x and y are called leading variables. Actually, they have lots of different names. Your book might call them, I think your book calls them leading. They could also be called basic or determined. I don't really care. I like leading because that's exactly what they're doing. Okay. But even more importantly, z does not get to lead off an equation. So z is called a parameter. whenever you end up, after you do your RREF, whenever you end up with a parameter, so one of your variables does not get to lead off an equation, you are going to have an infinite number of solutions. So this is the last scenario, okay? It's one of the least common, but it's kind of the biggest headache. So what I'm going to do is I'm going to go back to the equations that I have, and I'm going to forget about that 0 equals 0 because that's not terribly interesting, okay? I'm going to take the equations that my calculator spits out, and I'm going to solve for the leading variables, and I'm going to say vars, in terms of the parameter. Now, in general, you can have more than one parameter, but it's not going to show up in this course, okay? The way I do that is I simply go to my equations and I move the terms involving the parameter to the right-hand side. So I'm going to pick this up and I'm going to move it over there by subtracting it from both sides. So it's going to cancel on the left and it's going to become a minus z over 5 on the right. This one, I'm going to move to the right-hand side by adding it to both sides. So it cancels on the left and it shows up as positive 3z over 5 on the right. So basically, I'm going to get x equals 7/5, which was already over there, minus z over 5. And I'm going to have y equals minus 16/5 plus 3z over 5. Okay. And z is free to be whatever I want. Okay. That's why I have an infinite number of solutions. So the way I kind of write this in my solution is I say z equals z. It's free to be whatever I want. But once I make that choice, x has to be 7/5 minus that choice over 5, and y has to be minus 16/5 plus 3/5 times that choice. As long as x and y follow those rules, I'm going to have a solution to my system of equations. Okay. In point format, you would write it like this. So the x piece is 7/5 minus z over 5. The y piece is minus 16/5 plus 3z over 5. And the z piece is just z. And that's point format. Okay. And that's the last example I wanted to do for you. So your calculator, this RREF stuff, doing it by hand is extremely tedious. It takes a long time and it just has so much opportunity for errors. So use that RREF command and basically let it do kind of the heavy lifting for you, and you practice interpreting what comes out. Most of the time, you're going to have the same number of equations as unknowns. You can just read off your answer like the first example I did. Some of the time, you're going to have a row of zeros and then a 1 at the end, which is telling you there are no solutions. Okay. And a small portion of the time, you're going to end up with one equation kind of going away, and you don't end up with really as many equations as unknown, so you're going to have a parameter. That's when you're going to have an infinite number of solutions. The way you write down those solutions as you solve for the leading variables, the ones that get to lead off an equation in terms of that parameter, like I just did. Okay, thanks for watching.